Welcome everyone. Today we are going to look into about the redox reaction. What is a redox reaction? Here are a few examples where redox reaction takes place. At your extreme left, you can see the rusting of iron is taking place. So what is that? Here, iron material is been getting rusted. Here you can see a magnesium ribbon is burning by producing a dazzling flame. Photosynthesis reaction is taking place, whereas a car battery, pencil cells that we are using in our daily life. So, how these things are related with the redox reaction? Let's understand. Redox reaction involves reduction and oxidation reaction simultaneously. For example, as oxidation takes place, oxidation means the loss of electron. Here you can see an element which is also known as an electron donor. Hence, it loses its electron. Loses its electron means the oxidation reaction is taking place. Whereas you can see an electron acceptor in green color which will accept the electron and undergoes reduction reaction. So, for undergoing redox reaction, we need an electron donor and we require an electron acceptor. An electron donor will donate its electron, whereas an electron acceptor will accept that particular electrons, and completely redox reaction takes place. Red for reduction, ox for oxidation. Next, the one that is the electron donor is also termed as reducing agent, as it helps in reduction reaction. Similarly, electron acceptor is also known as oxidizing agent, as it helps in oxidation reaction by itself undergoing reduction reaction. What is oxidation? A substance is oxidized if one of the following happens for a reaction. For example, oxidation reaction can take place by gaining of oxygen or by losing hydrogen, vice versa, by losing electron or by increasing its oxidation state. Now, what is oxidation state? Oxidation state means the valence electron. For example, sodium. Initially, sodium do not have any charge. It has 11 electrons, that is 281. So, it can readily lose one electron to attain its octet configuration. So, after losing one electron from sodium atom, sodium gains one positive charge. That is known as your oxidation state. So, increase in oxidation number. Initially, the oxidation number of sodium was 0, and then after losing electron, the oxidation number becomes +1. So, increase in oxidation number moving from left to right, it is known as oxidation reaction. How oxidation takes place by gain of oxygen? Here is an example. Calcium gaining oxygen, forming calcium oxide. Right, this is also an example of combination reaction. Similarly, magnesium ribbon, initially when we have seen magnesium ribbon is burnt in presence of oxygen and forming magnesium oxide. So that is also an example of oxidation reaction where gain of oxygen takes place. Next, combustion reaction. Combustion of methane produces carbon dioxide gas and water molecules. So the carbon atom in methane has gained oxygen and has been oxidized to carbon dioxide. So this is also taking place by gain of oxygen, or we can also define in terms by removal of hydrogen. The hydrogen atom in methane has also gained oxygen and hydrogen has been oxidized to water. Next, that is how the loss of hydrogen. So a substance is oxidized if it loses hydrogen. For example, ammonia plus 3CuO gives N2 gas. So ammonia has lost its hydrogen and converted into N2 gas. So it is oxidation reaction. Next, by loss of electron. For example, here, right, in this reaction, oxygen is also not there, hydrogen is also not there, but still it is an oxidation reaction. How? That is magnesium. As I told you, the elements that are existing in its elementary form, they are stable. Their oxidation number is 0 because at this moment they have not gained any electron or not lose any electron. But when it is combining with Cl2 gas, so it is able to form magnesium chloride, where the oxidation number, the charge of magnesium is +2, whereas Cl is -1. So moving from left towards right, the oxidation number of magnesium is increased by 2. Hence, it is an oxidation reaction. Whereas you can see chlorine, it was 0 and now it is -1. So it is decreased. So it got reduced. And this complete reaction we can also term as redox reaction. Few more examples, that is how the loss of electron takes place. So as I told you, magnesium will give out magnesium 2 plus ion and +2 electrons. So in this reaction we can say magnesium atom has been oxidized to form magnesium ions. Right. So this is an oxidation reaction, is defined on the basis of loss of electron as well. So let us recall, the oxidation reaction can take place by addition of oxygen or by loss of hydrogen, by losing electrons, and the agent that itself undergoes oxidation reaction, they are known as reductants, because if itself it is undergoing oxidation reaction, then they will help in reduction reaction. So the agents that helps in reduction reaction, they are known as reducing agent or reductants. The agents that helps in oxidation reaction, they are known as oxidizing agent or oxidants. So basically, metals are acting as an reducing agents. Now, oxidation, increase in oxidation state. So what is it? The oxidation state is also known as oxidation number. But what is actually the oxidation state? It is the charge an atom of an element would have if it is existed as an ion in a compound, even if it is actually covalently bonded. As I have shown you in magnesium chloride, that is magnesium is having +2 charge, whereas chlorine is having -1 charge. Various definitions of oxidation and reduction reactions are, that is gain in oxygen, loss in hydrogen, loss in electron, increase in oxidation state. For reduction, loss in oxygen, gain in hydrogen, gain in electrons, decrease in oxidation state. So, if you remember what is oxidation reaction, you can recall about your reduction reaction. Chlorine is acting as an reducing agent. Again here you can see chlorine is acting as an reducing agent. So you just need to remember, right, which elements can act as an reducing agent, which elements can act as an oxidizing agent. Similarly, here carbon is acting as an oxidizing agent, that is carbon converted into carbon monoxide, whereas metal oxide is acting as an reducing agent. Similarly, here tungsten oxide, which is also a metal oxide, again acting as a reducing agent, but non-metals, that is hydrogen, is acting as an oxidizing agent. Thank you. Stay safe. Stay tuned.